We saw how to use the epsilon delta definition to show that the limit as x goes to 1 of 2x plus 3 is 5. But we should also be able to use the epsilon delta definition to show that that same limit is not 6. We just have to be careful about the logic of the definition. So we need to show that instead of for all epsilon greater than 0, we actually need to show that there is an epsilon greater than 0 for all delta greater than 0. There is some x such that x minus 1 in absolute values is between 0 and delta, and 2x plus 3, so our function of x minus 6 is greater than epsilon. Okay, so let's see what epsilon to pick. So let's let epsilon be 6 minus 5. So that's the difference of the two limits, and that's 1, that's greater than 0. And let's let delta be greater than 0 be arbitrary. I'm going to pick my x to be 1 minus delta over 2, so that x minus 1 in absolute value is just the absolute value of negative delta over 2, and that's going to be less than delta and greater than 0. Okay, and if we plug that into our function now, the absolute value of 2x plus 3 minus 6 is 2 times 1 minus delta over 2 plus 3 minus 6. And expanding and collecting some stuff, that's just 2 minus delta minus 3, which is the absolute value of negative 1 minus delta, which is just 1 plus delta. And that's greater than 1, which is epsilon. So that's actually verifying the negative definition of limit.